This one is lesson 1-4, arithmetic, sequence, and series. So it says here, an arithmetic sequence is a series of numbers that has a common difference between any two consecutive terms. So let's try to illustrate that with the following examples. Okay, you have here, tell if the following sequence of number is an arithmetic sequence or not. So all you need to do is you subtract any two consecutive terms. Consecutive means next to each other. So this one will be 10 minus 5 is 5. 15 minus 10 is 5. 20 minus 15 is 5. So this is your common difference. Okay, so the common difference is the same. The difference is common. Okay, and so if that's the case, this one is an arithmetic series. Okay, so it is an arithmetic series or arithmetic sequence if the difference between any two terms is the same. Now let's try to look at number 2. It says 1 minus 0 is 1. 1 minus 1 is 0. Okay, from this alone, the difference are not the same. Okay, and so this one is not an arithmetic series. Okay, it's only an arithmetic series if the difference between any two terms is common or the same. Okay, letter B. Let's try to extend some sequence. Describe the pattern in the sequence, then write the next two terms. So the pattern here is, if we're going to subtract any two terms, this one is 3. 11 minus 8 is 3. 14 minus 11 is 3. So the pattern would be you add 3 to the previous term. 5 plus 3 is 8, plus 3 is 11, plus 3 is 14. So this will be plus 3, this will be 17. And this will be plus 3, this will be 20. So those are the next two terms. Okay? Number 2 is, the pattern is 11 minus 5 is 6. 17 minus 11 is 6.
It'd be 20, not 30, right?
Okay, so it will be what? The next term will be 29, right? Because the pattern is add 6. 5 plus 6, 11, plus 6, 17, plus 6, 23. So plus 6, that will be 29. And then plus 6 again, this will be 35. Okay? So knowing the pattern, you can extend a sequence of numbers.
Mr. Bucco, you put 30 instead of 20 in number 1.
Where is that?
Carla, you put 30 instead of 20.
17 plus 3 is 20. Okay, Carla. You have an additional point for listening.
Already said that. You just
I know. Okay. So, letter C is, given an arithmetic rule, a formula, okay? We're going to list 5 terms to come up with a series. So it says here, write the first 5 terms of each sequence given the following rule or formula. So for letter A, the rule is 2n plus 1. Okay, so here, n is, when the first term, n is 1. Second term, n is 2. Third term, n is 3. Fourth term, n is 4. Fifth term, n is 5. So we just plug in these values of n to the formula. Okay, so the first one will be 2 times 1, that's n, plus 1. That's the formula. We just plug in 1 to n. So this one will be 2 times 1 is 2, plus 1 is 3. Second term will be 2 times 2 plus 1. 2 times 2 is 4 plus 1 is 5. This is 2 times 3 plus 1. 2 times 3 is 6 plus 1 is 7. Fourth term will be 2 times 4 plus 1. This will be 9. And then the fifth term here is 2 times 5 plus 1. That will be 11. Okay? And so the series of numbers that we are looking for will be 3, 5, 7, 9, and 11. How did we get these numbers? Using this rule. Okay? The second rule is 5 times n. So again, first term, n is 1. Second term, n is 2. Third, n is 3, and so on. Fifth term, n is 5. So this will be, the first one will be 5 times 1, that is 5. 5 times 2, that is 10. Notice that I'm using this formula, 5 times n. So 5 times 3, that is 15. 5 times 4, that is 20. And 5 times 5, this one is 25. So the series of numbers will be 5, 10, 15, 20, and 25. Okay? And as you see, the common difference are the same. The common difference here is 5. The common difference here is 2. Now, in the formula, this 5 here represents the common difference. Okay, the common difference is 5. What's the common difference here? It is 2. Okay. Sometimes this one is the slope. Okay. Remember the formula y is equal to mx plus b. This is the same. Okay. The change, the average change will be 5. This one, the slope or the average rate of change will be 2. Okay. We will not solve this one. Okay. So that is your arithmetic sequence or arithmetic series. Okay, it is an arithmetic series if the difference is common. You can extend knowing the pattern, and you can write your own sequence given the rule or the formula. Okay, now there are different ways of writing. There are different ways of writing arithmetic sequence. Okay, the first one is you can write an arithmetic sequence using a recursive definition. Now, what is this recursive definition? A recursive definition is something that just gives you formula. It doesn't list down the numbers. So there are no numbers that you see here, but it tells you what's the first term and what is the common difference. Okay. So the recursive formula is written in this manner. A sub n is equal to a sub 1 when n is equal to 1. A sub 1 is the first term. Okay, let me write this one. This is the first term. And then to get the next term, you just add the common difference to the previous term. Okay, so this one here represents the previous term. Previous term means the term before. And so to get the next term, you add the difference. D is the difference. Okay? So, let's see here. A1 is the first term in the series. And common difference is your D. Okay? So the only thing that we have to know here, identify, is your A1, your first term, and your D. So let's try to do this one. Identify if the following sequence is arithmetic. If so, write a recursive definition of the sequence. So let's see if this is arithmetic. We said that it is arithmetic if the difference is common. So 8 minus 3 is 5, 13 minus 8 is 5, 18 minus 13 is 5, 23 minus 18 is 5, okay? So the common difference is the same. And so this one is an arithmetic series. Now we have to identify what is our A1 and our D. Okay, our A1 is the first term. The first term is, of course, you know, it is 3. And the common difference is this one, 5. So now you just plug in this A1 and D in this formula here. Okay, so this will be AN is equal to A sub 1. What is A sub 1? 3. Okay, if n is equal to 1, meaning to say n, the first term is 3. And then the next term will be the previous term plus your d, which is 5. Okay, that is n is greater than 1. Okay, meaning to say it's no longer the first term, but the second term, third term, fourth term, fifth term, and so on. And to get those terms, you just add the previous term and the common difference. So this one is your recursive definition. Okay, so meaning to say we are defining this one, okay, not by listing the terms. Okay, we are describing it recursively. So in number 4, this one is, what is the common difference here? This will be 7 minus 4 is 3, 10 minus 7 is 3, 13 minus 10 is 3, 16 minus 13 is 3. So A1, the first term is 4. Common difference is you have 3. So the recursive definition will be, use this formula again. A1 is 4 when n is equal to 1. And n minus 1 plus your d is 3 when n is greater than 1. So what are you doing actually here is you just plugging in the values of your A1 and your D, okay, to write the recursive definition. Okay, next, this one here. The common difference is 20 minus 25 is negative 5, 15 minus 20 is negative 5, 10 minus 15 is negative 5. So the difference is common, they're all the same. So this one is an arithmetic series. Now let's identify your A1, which is our first term, that is 25, and our D is equal to negative 5. So the recursive definition will be A sub 1 is 25 if n is equal to 1, and n minus 1, the previous term, plus the difference is negative 5 when n is greater than 1. Okay? And this one is 4 minus 2 is 2, 7 minus 4 is 3. This one tells you that this is not an arithmetic sequence. And so there is no recursive definition. Okay, so you can only have a recursive definition if it is an arithmetic sequence. Okay. The other way of describing a series is by using an explicit definition. Okay. What is an explicit definition? This one here. Okay. AN is equal to A1 plus D times n minus 1. And this formula allows you to find any term in the sequence. Like, I want to find the 50th term or the 100th term, okay? I am going to use this formula. And so that is our goal this time. How do we write a formula given a sequence here. Okay, so the first thing that you do is, because in the formula you want your A1 and your D. A1 is the first term. So what's A1 here is, the first term is 1. And what is our D? D is the common difference, okay? 3 minus 1 is 2. 5 minus 3, okay? Let's see. 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. So our D is 2, okay? And now you're going to write down the explicit formula. So which is A sub n is equal to A sub 1 plus D times n minus 1. So I do just plug in these values here. So now I have here an is equal to a1 is 1 plus d is 2, then n minus 1. And then you're going to simplify. So this becomes 1 plus 2n. 2 times n is 2n. 2 times negative 1 is negative 2. And you combine similar terms. So this one is an is equal to 1 and negative 2 is negative 1, okay, plus 2n. So now this one is your formula, okay, or your explicit definition, okay? Explicit definition or explicit formula. And as I said a while ago, it allows you to find any term. Now let's try to find the 20th term. You now use this formula, okay? So an would be A20, means the 20th term, okay? So this will be negative 1 plus 2 times n. N is the number of desired term that you want. What is the term that you want? You want the 20th term. So that is n is 20. Okay? Whatever is your number here is the number there. So a raised to 20, I mean a sub 20, the 20th term will be negative 1 plus 40. The 20th term will be negative 1 plus 40 is 39. Okay? The meaning of this is, if you extend this up to the 40th term, the term in the 40th term will be 39. It's going to be 1 plus 2 is 3, plus 2 is 5, plus 2 is 7, plus 2 is 9, plus 2 11, plus 2 13, plus 2 15, until you will reach the 40th term, you will see it is 39. Okay? So this is the recursive and this is the explicit. Okay? So let's try to solve the last one. So this one is, what is A1? The first term is 3. And then D, the common difference is 6 minus 3 is 3, right? 9 minus 6 is 3. 12 minus 9 is 3. So the common difference is also 3. Okay. So you can now write the formula an is equal to a1 plus d times n minus 1. And so you're going to plug in this formula. I mean these values. A1 is 3, d is 3, n minus 1. And then let's simplify. An is 3 plus parenthesis, so distribute. 3 times n is 3n. 3 times negative 1 is negative 3. So now an is equal to 3 minus 3, combine the numbers. 3 minus 3 is 0, so I just cancel that. And so the explicit formula or explicit definition is 3n. The formula for this is this one, your explicit definition. Okay? So using this formula, we can now solve for the 15th term. What's the 15th term? So A15 is equal to 3n. This will be 3 times the 15th term is equal to 45. Okay, so that is the lesson for today, arithmetic sequence, how to find the common difference, how to extend an arithmetic sequence, how to write an arithmetic sequence using recursive definition, and using